surface.
Okay, welcome back to the new episode of our podcast, Blue Shift. This one is entitled "Mapping Inequality: Visualizing Humanity's Impact on the Planet." And today we're going to go to my close friend and colleague. Ben Henning is a professor of geography at the University of Iceland. And he has a really weird profile, like for people that are working on climate change and also ocean. He's a geographer and he is really a specialist on visualization and geospatial analysis. He's also working in a project, the Worldmapper, and I would like to start the conversation with you about what about this project, what about the Worldmapper, and how the Worldmapper will contribute to the climate change, or maybe even the applications to climate change. Welcome.
Yes. Thank you very much. And just to add to the weirdness of my profile, I actually didn't even start studying geography in the first place. I started with German literature and language studies and philosophy, and geography was my minor. So I got into this whole field of mapping geographic information systems, remote sensing through my studies when I wanted to take a GIS course, and I wasn't allowed to because I was a geography minor. And I thought, that's not fair. So I switched to geography as a major. And that really got me into the whole field of geospatial analysis, these kind of things. And the rest is history, basically. And that kind of fast forward got me into being engaged with Worldmapper. And we're sitting here at the right time because Worldmapper has its sort of 20th anniversary now. It was founded, if you want to call it that way, in 2006 at the University of Sheffield by Professor Danny Dorling at the time, and he stumbled over a paper by Gastner and Newman introducing a new algorithm on creating cartograms that are distorted maps that resize countries or areas according to quantities, spatial data or quantitative data. And that led to the idea of Worldmapper as a sort of online repository or an online atlas that maps all sorts of things about global spatial economic inequalities, social spatial and economic inequalities. And that was about 20 years ago, and I joined the Social and Spatial Inequalities Research Group in Sheffield to do my PhD there, where I worked on improving the methods that we're using in Worldmapper for mapping basically all the spatial data that we can get hold of. And it was also a time when a lot of international organizations, World Bank, United Nations and so on, started releasing a lot of data publicly on the internet. There was an age before the internet, but the 2000s were the era when the internet really became ubiquitous and available to everyone. And all these statistics started becoming available. And that really kind of helped to realize a project like Worldmapper, because most of the work on mapping something is the actual gathering and collecting of the data. And that led to Worldmapper basically being put out there as a free resource for teaching, for science, for research, and for basically science communication of geographic information.
So as far as I can see, maybe for example, could be like a huge advance in your topic because of in artificial intelligence as well. So maybe it could be having a kind of promising future, or you don't see this kind of promising?
There is, of course, the risk of what is called artificial intelligence, mainly being language models, machine learning, kind of the advancement of machine learning that can produce language that sounds convincing. But obviously, we need to have some certain responsibility in working with the data and understanding what happens. Like the AI tools that we use nowadays are a little bit like a magic black box that produces an output, but not necessarily always telling us what happens on the inside. And there we need to be quite responsible with how we treat the information that we put in and that we get out. And I would say there's at least for the time being, there are some limitations to trusting the outputs. And I think we all know that the great examples of AI giving you an output of some information that it's very convincingly producing as a fact or as a reality, but that in fact is the greatest bit of misinformation that you could possibly get. And that's, I guess, part of the justification why people like ourselves or sciences and universities are still needed in order to scrutinize data, to ensure there's certain there's a certain responsibility behind the information that we are publishing, and then also this responsibility to communicate scientific information adequately.
Yeah, you're right. And maybe you are in an island, a massive one, Iceland, and we are in a kind of tiny, compared with Iceland, the Grand Canaria, and you are the local coordinator of a master of islands. Me, I'm the local coordinator of the master. Sometimes it could be a nightmare, I know. and you can see there, for example, islands is a really particular entity that maybe, for example, there are so fragile ecosystems. So maybe how do you approach to live in an island into your research line? How is important being an island or not?
I've been living on islands for a long time. I did my PhD on an island that feels much less like an island, the UK or England or Great Britain. As an island, but when you move to an island that's far away from everyone else, like the islands that we currently live on, Iceland, I would still argue, is a relatively small island, but in the context of Gran Canaria, of course, it's a huge island. We have this big neighbor, Greenland, on the other side, and we've seen in global geopolitics how islands also play a quite strategic role through their locations, through their connectivity or disconnectivity. What I would say about the specific role of islands in this, also in mapping global data, what we've been doing in Worldmapper is that islands are very often still neglected because they're so small. So if you look at a world map, you hardly ever see the islands, at least the smaller ones, but they play a quite pivotal role in, say, in people's livelihoods, in the global connectivity, as strategic points, as geopolitical points. We don't need the example of Greenland, but we can see a lot of other geopolitical examples in the South China Sea, for example, contested islands. That's all about politics claiming resources. And then these islands are surrounded by the oceans, which provide much of the big resources, minerals, fish stocks, etc., that actually feed into the livestock of not just the local populations, the local communities, but basically at a global scale also feeding the world's population, for example. And islands in the end also are on the edge of the oceans that are crucial for climate change processes, where the oceans are storing global heat, where oceans are the first affected or amongst the first affected ecosystems by climate change processes. So they are quite critical to actually get an understanding of how Iceland fit into this global picture that we very often overlook when we look at global processes and dynamics.
Yeah, maybe for example, one of the things you approach your research line, I think, is amazing, because when you are a researcher, you are in a kind of your tiny bubble of research lines. So maybe, for example, having got another colleague like you, maybe, for example, dealing with different stuff, and there are some kind of surprising ways like humanity is impacting, our planet. Did you highlight these kind of impacts in a way that I'm not going to see in like our conventional way? This like taking samples and you will see like a long-term trend or maybe a spatial trend or whatever, as I've seen, for example, in this island about the massive human settlements that were on the coast. Have you seen in a different way in your research how humanity is affecting the planet?
I think part of what my research is doing, or at least this sort of visualization, science communication aspect, is to present information in a different thought-provoking way, that people look at the topics that we know about already from a different perspective. And I guess what we've been doing with Worldmapper, but also in general, when you produce narratives about science outputs, is that you put people towards thinking and reflecting about particular places. And visualization can become part of a research tool itself. Very often it's used just as a science communication tool, but very often visualization also helps us to see some patterns that we otherwise wouldn't have noticed. And that we can transfer that from the land area of what we've been doing in Worldmapper towards the oceans, where we benefit highly from global satellites now for decades, starting to collect long-time series of information that help us to understand the transformation and the changes that are happening in these spaces that we didn't have much knowledge about, and we still don't have much knowledge about the oceans in the past, whereas we knew a lot of details about humanity and how many people live and how rich or poor they are, what diseases they have. We know very little about this from the oceans because we we don't do a census, a complete global census of fish stocks or these kind of things. We always just produce this kind of data information in many cases where it becomes economically relevant. And that's where science, of course, needs to step into giving us this more global, comprehensive understanding of these processes that we sometimes can't monitor just with satellites. And that's, of course, much more challenges in the spaces that we don't live in.
Yeah, for sure, you're right. And how, might, coastal communities contribute to mapping marine change?
The communities, I guess you're speaking about people who live in the communities. And the coastal communities in many spaces and places on the planet have lived in these environments for generations, for many
millions of years.
Millions probably not.
No, millions of years. Yes. Yeah, right. Yeah.
And they have this knowledge about the places. Because they adapted to these environments and learned to live in harmony. Probably it sounds strangely, but in our understanding of sustainability, they have learned to live with these environments in a sustainable manner, whereas we have started to live very unsustainably, like. Coming back to fish stocks, for example, overfishing being a major issue, that's not triggered by the local populations who have learned how to live with the local fish stocks that they have, how to treat their local marine environments in order to protect them for their own sake and for their own livelihood. Whereas these sort of more global processes, they go to the resources, extract them, and then they move on. That's the sort of more global capitalist process that we see play out. And if we rediscover the local knowledge, the local communities, and how they live within their limits of what the nature has to provide, I guess we can learn quite a lot about how we probably have to change our livelihood, our lifestyles, in order to live a more sustainable.
Yeah, that's the reason, for example, how important is a core, of utmost importance, the local knowledge. The knowledge has been, sometimes overlooked, for ages, so even for our previous generation and even our current generation. So it's really important. Working in the terrestrial realm has its own challenges, but working in the ocean is a different league. There are so many, I don't know, how do you say, maybe challenges or boundaries. What are the boundaries that you got working as a geographer in the ocean?
The first boundary is we have learned to organize our land areas quite neatly, whether you like it or not. But we started drawing lines
with fences,
countries and fences, and that also helps, of course, to approach these areas statistically. We gather information in administrative units, and we started collecting all this information. The oceans are a little bit more tricky. We started drawing these lines. We've got the exclusive economic zones, for example, that were established in the 70s, 80s, I believe, that kind of extend the same idea onto the oceans, but then we have these oceans, or large amounts of the oceans are being shared spaces, which requires global management, global agreements. How do we deal with them? But from a scientific perspective, referring a little bit to what I said before, one of the main challenges is how do we actually know what's happening inside? So if we think about over 2/3 of the planet's surface are oceans, but the amount of knowledge of what we have, what's happening inside these oceans, is so small compared to what we know about the land, because we need to go underwater. The satellites have only so much capacity to actually tell us what's happening underneath. We haven't even managed to map the entire seafloor yet. That's an ongoing effort. Yeah. So there's a lot of these black holes, and we are venturing out to the moon and the Mars, and we know a lot more about these spaces sometimes than we do know about the actual the physics and the biosphere of the oceans than we do know about some of the other spaces. So these are some of the challenges of finding the right methods to extract that information, because we can't approach it the same way as we can do it on land. So we need to develop methodologies that help us, for example, you mentioned community mapping, for example, to use the ships that are out there to help us collecting information about fish stocks, about migration paths of whales and other sea life. So we need to extend this kind of effort to understand the oceans in their complexity, and also how it affects basically our climate systems, not only our resources that we utilize and extract from the oceans, but how it might affect actually our global processes.
And it's going to be like a huge struggle, because sometimes in the ocean there is a kind of a topic, or maybe like an idiom. Most of the people say it, out of mind, out of sight, out of mind. So maybe most of the people, they don't try to dig into that, just trying to fill in these gaps of knowledge, because there could be certain sectors that are really comfortable with this in the current situation. So it's a little bit tricky. Yeah, you're right. Had you got any examples where their visualizations have influenced public understanding of policy?
It's a bit tricky to say like there's this one image that has changed everything. We do know some of the visualizations that are quite prominent. We know the hockey stick curve for climate change that has become a quite neat analogy from, let's say, remote sensing. We know the first picture that was taken of Earth in the 70s, where you see Earth just being a small blue dot in the image. That kind of changed imagination of people. And arguably, probably maps are not always achieving this one big moment where people are shifting their perspective. I think if we understand like mapping, spatial visualization more as something that feeds into the bigger picture, that helps us to understand, to see things in a different light. I think that's a much more powerful aspect than saying like we need this one new picture, this one new image that changes the whole narrative. It's like using geovisualization as a complementary element to narratives that helps not only decision makers to change their perspectives, but that becomes much more common knowledge or common use in let's say education, in schools, etc. I think it's more about these kind of small bits and pieces that result in a bigger mosaic of understanding and seeing the planet differently. And that's kind of coming back to the initial question about Worldmapper. What we're trying to do is to provide new perspectives on knowledge that we already have for people to ask new questions. When you see a map that's distorted by a certain indicator and suddenly you see shapes and patterns instead of seeing a data table with numbers, then you start asking different questions than you would have done before. It's not this one image, but it's the multitude of new perspectives that you're gaining that help us to challenge our own perspectives or biases that we have, what we think we know already about the world. And that even happens when I'm producing my own maps and I visualize a data set and suddenly I see like, oh, why is this suddenly so big in the map? And you start looking into the topic further. So it's a tool for engagement, for asking these questions. And you see this very often in the engagement with the general public, that they like to talk over pictures. And then you come to this kind of a picture being worth a 1,000 words. That's then true for these kind of maps and visualizations without having to have one iconic image.
It's a really great, interesting way to promote independent thinking as well. So maybe it's something that I think we are lack of, or maybe, for example, not promoting that stuff, So I think that's really way. So and now, for example, with the students, please.
No, I was just thinking, and maybe also thinking about like those who actually make all these big decisions in the world. So decision makers. They might get a big report. Think about the IPCC report. Have you ever read it from front to end? And no politician, no decision maker will ever read this. But if you think that actually it's the images, it's the visualizations, it's the key summaries that are core to, or that provide the basis for the decisions that they are taking. So you can see how powerful suddenly these kind of small bits of visualizations, of translating science into something understandable become, when this is the only thing that maybe a president of a country reads before coming to a summit and making decisions. So they rely on this information being relevant and telling them not the right story, but telling them what's behind the data. They will not look at the data tables. They will probably not even look at charts and graphs that look complicated. So that plays a quite important part in translating your knowledge.
You're right. And maybe, for example, now that you are a professor, and me, I am a professor as well, there's, I think, a big piece of this pie, big chunk of this pie is about students. So maybe I think, what is always going to be your advice for young researchers to be interested in, in combining your topic maybe could be geography, geospatial analysis, technology, and social impact. You think it's important? Is that the thing is a way or a path that maybe somebody needs to follow in the near future?
I think, especially when it comes to geospatial technologies, I always used to say, like, if you learn GIS, if you learn these remote sensing, all these tools in an advanced way, you will always find a job. That's still true because you need to have this knowledge that will get you into specialized professions, and AI is not going to take that away because knowing the basics is a key to actually utilizing these tools. If you don't know what you put in and get out, what I was describing before, if you don't know what these methods are useful for and how you can deploy them, then GIS can be the most useless tool if you don't know how to combine data sets. And AI in the contemporary world is just one little extra helper that makes you more efficient in this path. But what I would advise students as well is to not just see these kind of skills as something, as the core of what you should be learning, but the core of what you should be learning is the integration of different things. So if you're very good at working with geographic information systems, maybe using programming, you've only learned half of what you actually need for making this matter in a future career. And this kind of seeing different perspectives, seeing different angles, also combining, like coming out of your comfort zone, combining social science and environmental science approaches. I think we need to, in most of our disciplines, we need to be much more interdisciplinary in our work. And even if let's say your master thesis is about a particular aspect, be it a social science focused theme or environmental science focused theme or whatever else, you should try to integrate the other side, the other perspective, because that's where the societal relevance comes in. That's what I would really encourage students to really take into consideration. It requires doing a lot of reading. It requires to be very open-minded, to be curious. Not just seeing your degree as something you study to have the paper at the end and that will land you the job. That's not true anymore because there's so many university degrees being given out, but what makes you different is like how you can apply and utilize it. And learning about methods is one part, learning about theories is one part, but this whole integration, you really have to want it. Otherwise, you probably should reconsider whether what you're studying is what you really need and want for your own
right.
future.
Because maybe sometimes with the disciplines, I think for your PhD, you would like to be in academia, involved in academia, or maybe as a PhD holder, you need to master like maybe minimum 2 disciplines. I think minimum, maybe 3, even 4. There could be an asset, but maybe just only focus on only one. I think is out of date at the moment. So maybe we're living in a kind of an era that maybe most the interdisciplinary science is going to have a huge power in our daily lives.
And like when we talk about AI, but that was even before AI came along. Knowledge is now out there. We have it at our fingertips. We can look up a lot of information and find it immediately instead of having always to go to libraries to identify that knowledge. But the more important it becomes that we are very critical with the knowledge that's being presented to us and questioning and challenging the perspectives that we've been given. So the sort of critical perspective is really one of the core things that you cannot just teach in a lecture, but you have to engage with it. And it's not just about like going through an exercise, but critical thinking comes through critical debates and discussions and engagement with the material. I think that's a core skill of what we should be teaching at university and try to get students engaged in, but which on the other side also, if you're a student, you want to do a PhD, you should have a genuine intrinsic interest beyond receiving your degree or having a doctor in front of your name.
It's not as easy as you listen that as you can see. It's just trying to put into practice. It takes time, and even they need to have like a change of paradigms or model for study of professors, and maybe how to engage students. I think we need to be a little bit a path forward, and in that aspect, that's for sure.
And maybe just to add that one last point, because we've been talking so much about visualization, science communication, I think that's also one very critical point I would encourage every student to really consider is science is not there because it exists naturally, but we matter because somebody decides to give it funding and money. And in most of our countries that we live in, it's still society providing at least part of this, funding the universities, So it's our responsibility to give something back,
sure,
and this kind of translating what you do into common understanding is key to this, and really wanting to engage with the public, not just seeing it as a little add-on when you apply for a grant and you say like, yes, I'm going to put this information out there, but really wanting to engage with the general public is a key point, and thinking about ways of how you can explain your work to an audience that's not as specialized. I think that's quite important. To
That's
consider.
great. Really good point. That's one of the main reasons of this podcast as well. So the answer, just to wrap up, all this conversation, that it has been lovely. Ben, what is that? Could you give me like maybe a couple or maybe one key takeaway? Or maybe, for example, how humans are reshaping our planet, and that everybody, the public audience should understand that.
It's very challenging to put me down to one takeaway,
for sure.
But I think half the takeaway was in your question already. I think we should really be mindful that human activity really now reshapes how we are living on and with this planet, and it's being thrown back at us because like the responses of the planet beyond humans are affecting our everyday lives through global environmental change, but it also affects global social change. And trying to really put this link between human and environmental relationship into the center of our work is probably one of the key takeaway messages. And not just, we need fundamental research, but we also need to step back, even those who do fundamental research, to step a little bit back and look at the bigger picture that helps us to understand this role of the humans for our very own sake. I mean, the planet doesn't care about us being here or not. We mostly do this for our own existence and for our own livelihoods and for being able to sustain 7, 8, 9, 10 billion people living relatively peacefully and with resources that are not depleting. And that's going to be a major challenge, as we can see from the times that we live in. So it's not this one takeaway message that,
you're right.
we need to take responsibility for this and understand these impacts much better than we do it nowadays, and be creative with finding new solutions, like rediscovering local knowledges, for example, local communities that can also serve a much bigger population or be templates for a more sustainable pathway.
I agree entirely about that. Anything else you would like to add to this conversation, Ben?
It's been a real pleasure. Thank you for having me here. And we could go on for hours, but nobody's going to listen to a 5-hour podcast. So I think we should probably wrap it up here. Thank you very much for having me in this episode.
It was a great pleasure. So guys, here's the end of this episode of this podcast, The Blue Shift. So stay tuned and stay blue. See you in the next time.
Beneath the surface, out of sight,